Yeah, okay. So centroid and orthocenter. So the first thing we're going to look at is altitudes and mediums. Basically, pretty simple to identify. An altitude of a triangle is a segment from a vertex to the opposite side that is perpendicular to the side or the height of the triangle. So basically, the altitude connects to this vertex. So this would be our vertex. And this would be the opposite side. And so the altitude will connect to both of them. And it does so perpendicularly, so at a 90-degree angle. So that is the altitude. Okay. The median, on the other hand, is slightly different. The median of a triangle is a segment from one vertex. So this would be our vertex. To the opposite side. This is the opposite side. But it does so at the median. So it's not necessarily perpendicular to it. What it intersects at is this median point, basically the median of the opposite side. The median means it's the midpoint in that line segment, so it creates two congruent halves. So if I have that line segment, CB, my median would be the point which cuts it into two congruent halves. So this would be my median point. So that median is going to connect to the vertex, the very top of the triangle, through that median point, and that would be my median. Okay, questions about this? And so basically you should be able to differentiate between these two. Again, altitude from the vertex perpendicular to the opposite side, the median from the vertex to the midpoint of the opposite side. Okay. We also are going to look at what is known as a point of concurrency. Our point of concurrency is basically just the point where three or more lines intersect. So the point of concurrency here would be this point right here. Oops. Let me try not to. This is our point of concurrency. Okay, pretty simple. And so now we're going to get into orthocenter and centroid. So this is the gist of what we're getting at. So the orthocenter and the centroid are basically what you're going to have to be able to differentiate between. The orthocenter is where the altitudes of a triangle intersect. So basically we looked at altitudes. Altitudes go from the vertex to the opposite side perpendicularly. So our altitudes here would be this one, and this one. So the orthocenter is going to be basically where those different altitudes intersect. So this point right here is our orthocenter. Okay, whenever you think of orthocenter, you want to think of altitudes. Okay. Whenever you think of centroid, on the other hand, you want to think of medians because your centroid is going to be where your medians intersect. So we looked at medians. Medians went from the vertex to the midpoint of the opposite side. So these would be our medians. Right, they are the midpoint of both of those opposite sides. U is the midpoint of R and T, W is the midpoint of R and S, and V is the midpoint of T and S. And so that point where they intersect, where the medians intersect, is going to be our centroid. Okay, so whenever you think of orthocenter, think of altitudes. Whenever you think of centroids, think of medians. Okay. As far as centroids go, centroids are always going to be located inside of the triangle. So you're going to have a lot of questions that ask you to identify the location of the centroid. The centroid is always going to be inside the triangle, always inside. The orthocenter's location actually depends on the type of triangle, and so we're going to look at that. So again, centroid's always on the inside. No matter what type of triangle you have, always on the inside. Whenever you have an orthocenter, on the other hand, your location depends on your type of triangle. So if you have an acute triangle, all the angles are less than 90 degrees, your orthocenter is going to be on the inside. So this would be my orthocenter. So if you have an acute triangle, your orthocenter is on the inside. If you have an obtuse triangle, so one obtuse angle, two acute angles, your orthocenter is going to be on the outside. This is my orthocenter. And whenever you have a right triangle, your orthocenter is going to be on the triangle. So this would be my orthocenter. Okay. So the location of the orthocenter depends on your type of triangle. Your location of your centroid always on the inside. Okay. So basically what we've done so far is we've differentiated between an altitude and a median. We've differentiated between an orthocenter and a centroid, and then we've differentiated the locations of centroids and orthocenters. Okay, we're going to look at one last thing, and it's the centroid ratio theorem. Remember that the centroid connects all of our different medians. Our medians connect from our vertex to the midpoint of our opposite side. And remember that our centroids are always located on the inside, okay? So that takes us into the centroid ratio theorem, which basically says, along each median in a triangle, the distance between the vertex and the centroid is twice the distance between the centroid and the opposite vertex. So basically, here we have a centroid. Here we have those medians. Remember, these are medians because they connect to a vertex and they meet at the midpoint of our opposite side. So these are the midpoints of our opposite sides. Okay, and then that red dot would represent our centroid. Basically what this is saying is that the distance, we can look at A and G, the distance from here to here is twice the distance between here to there. So the distance from A to G is twice the distance of G to D. That's basically what it's saying. So if this is 2, the distance here would be 4. Has 2 times 2 is 4. If the distance here is 3, the distance here would be 6. So basically, the distance of our line segment, which is opposite our median, is going to be 2 times the distance of our median. So that is what this is saying. So I'm trying to see how to show this better. So here we have one median. Oh, yeah, I can use that. Here we have one median. We know it's a median because it connects to the vertex to the midpoint of our opposite side. Our opposite side is AC. What this theorem tells me is that this distance is twice the distance of that opposite line segment. So if this line segment is 7, then this would be 2 times 7, which is 14. So that is what the centroid ratio theorem tells us. Okay. Here is an example of this. It says Q is our centroid. What is the length of line segment QM? Well, here we have QM. And we know that the line segment opposite that is 2 times the distance. So this distance would be 2 times QM. So I can write that as KQ is equal to 2 times QM. Okay, plug in my equations. And then solve for X. You can do it in your calculator or you can do it algebraically. If you were to do it algebraically, you would multiply here on both sides. Okay, now you want to go ahead and move 6x over. So negative 2x equals negative 8. Divide by 2 on both sides. X is equal to 4, and now you're just plugging 4 back in to find the distance of QM. So 3, 4, minus 4. Plug that into your calculator. That's just 12 minus 4. So this distance is 8. Okay, so you're able to create the equation KQ equals 2 times QM because the distance of this side is going to be 2 times the distance of this side, which represents your median. So that's how we'd use the centroid ratio theorem. And those are the only types of problems we will really get whenever it comes to centroid and orthocenters. Other types of problems will basically just ask for location. You're not really solving for anything. Math-wise, it's only going to be the centroid ratio theorem where you are going to solve for example X in this instance. Okay. So just an overview. The orthocenter is going to be where all your altitudes meet. So here are your altitudes. Remember that your altitudes connect to your vertex and your opposite side perpendicularly. So these would be your altitudes. The points where all those altitudes meet are going to be your orthocenter. Okay. What we know about the location of the orthocenter is that the location depends on your type of triangle. It's going to be inside for an acute, outside for an obtuse, and on for a right triangle. Okay. Your centroid, on the other hand, is going to be where all your medians meet. So you're going to look for the midpoints. This one, this one, this one. Where all those medians meet are going to be your centroid. So that point is going to be your centroid. And we know the location of the centroid is always going to be on the inside, no matter what type of triangle you have. And we also know that the distance between the vertex and the centroid is twice the distance between the centroid and the side opposite. So that is the problem that we just went over. Okay, questions, concerns? I have already uploaded a condensed version of everything we've looked at. I want to say it's this one. So this would be a condensed version of what your orthocenter is, an example of it, where it's located, your centroid, what it is, where it's located, always on the inside, and then that theorem that we just looked at. Okay, so this is a condensed version of everything that we've looked at today. All right, but we will, or I'll post some example problems for you to reference tomorrow before independent practice, but any questions? Okay. If there's no other questions, you guys may log off, and I will see you guys on Wednesday because I am testing tomorrow. Okay, bye guys. Yes, yes you can.